All right, welcome back, guys. Next section of notes for today, getting into triangle inequalities. So obviously we've been talking about a lot of different properties with triangles, and specifically we have some different things dealing with inequalities that we know about them relating to the sides and the angles. So we're going to talk about that today. So label for today, 5.4, triangle inequalities, and then date today is the 8th if you would like to add that. An objective is we want to be able to use these inequalities to either solve for side lengths and angles, or at least be able to create inequalities with side lengths and angles and be able to tell me how big or small they could be. Okay, so first thing here, since we are going to be talking about inequality so much, I want to make sure we review that term. So an inequality in math is just when, I want you to write this with me here, inequality is when one value is greater less than another. I'll write this out here. Okay, when one value or quantity, whether it's a number, whether it's a side length, whatever, is always greater or less than another. And remember, just for clarification, you'll see these symbols a lot, so we want to make sure we understand which ones they are. Remember, if the symbol is facing the left side, this is the greater than sign. Greater than sign, and then if it's facing the other direction, that is the less than sign. Okay, and hopefully you know, obviously the symbol is going to open up towards or face the direction of the larger quantity or the larger value, but just for a quick little help, greater than faces or opens up to the left, less than to the right. Okay, so with that, we have some theorems that we can talk about here with triangles. So first one here is the triangle inequality theorem. Okay, the side angle triangle inequality theorem. That part is important. Okay, side angle triangle inequality theorem says this. It says if one side of a triangle, okay, if one side of a triangle is larger than another. Okay, if one side of a triangle is larger than another, or another side, then the angle opposite the larger side is greater than the angle. Okay, give you a sec to write all that down. So we were saying if one side of a triangle is bigger than another, then the angle opposite of that bigger side is going to be greater than the angle opposite of the smaller side. Okay, well, obviously we'll draw a little example with this here. Okay, but if one side of a triangle is larger than another, then the angle opposite the larger side is greater than the angle opposite the smaller side. Okay, so for example here, scroll down. Let's say we have this here. Let's say we have this side length is 7 and this side length is 9. So all I need is 2 of the side lengths here. And notice we're not saying that we know exactly what the angles are or what their measure is, but we're just saying one is going to be greater than the other. So if 9 is greater than 7, and let's just name this, let's say angle A and angle B. Okay, just for the sake of this problem. Okay, if 9 is greater than 7, then the angles opposite of them are going to follow the same idea. So angle opposite of 9, in this case angle A, is going to be greater than the one opposite of the smaller side, angle B. Okay, this is the idea behind this theorem. Okay, like I said, it's not necessarily telling us the exact measure, but just tells us which one is going to be bigger than the other. Okay, so next one here, the converse of the same side angle, triangle inequality theorem. And you guys can obviously abbreviate these as needed. But we're going to do the same thing except the converse. Okay, remember we've talked about this before. Converse is when I take the hypothesis and the conclusion and I just switch them. So in this case, we're going to switch it around. We're going to say if one angle is greater, let's say if one angle of a triangle, does need to be in a triangle, of a triangle is greater than another. If one angle of a triangle is greater than another, then the side opposite. Give you a sec. If one angle of a triangle is greater than another, then the side opposite of the larger angle is greater than sorry guys, sorry about my handwriting as always, is greater than the side opposite the smaller angle. Okay, if one angle of a triangle is greater than another, then the side opposite of the bigger one is going to be greater than the side opposite of the smaller one. Okay, so if I'm looking at this here, another example, same kind of thing. Let's draw a triangle real quick. You can just make some space in your notes. And let's say we'll call this angle C here an angle, or let's make it different. Let's say we'll give actual numbers here. We'll say this is 57 degrees and this is 42 degrees. Let's say triangle ABC. Okay, and we also could figure out the angle, the measure of the third one, but that's not important on this one. So if I'm looking at a picture like this and I see this here, what I can say is I have my larger angle, 57. So we're going to say if 57 is greater than 42, then the idea here is the side opposite of the larger one, so in this case AC, is going to be greater than the side opposite of the smaller one, so in this case BC. Okay, so that's what I'm looking for, is I'm saying what's my biggest angle, that's going to correlate, or that's going to be opposite of my biggest side. And then same thing vice versa as well, like we talked about in the last theorem. Okay, so let's practice this a little bit and kind of see what this looks like in different problems here. All right, so first one here, move myself out of the way. Okay, I want you to take a second, I want you to pause your video, and I want you to sketch this triangle with all of the points and the measurements there. Okay, so we have this here. We're given this triangle PQR, and we're told we want to list the angles in order from least to greatest. So again, notice I'm not saying the exact angle measures. I don't have a way to figure those out, but I can at least list them in order. So what I'm going to do here first is I'm going to list the side lengths in order. So if I'm going in order from least to greatest, the least or the smallest side would be PR. So I'm going to say this for sides. We'll say PR is less than, okay, what's the next greatest side? Next greatest side would be 8.8, so that's PQ. So PR is less than PQ, which would be less than the biggest side. The biggest side is going to be 9.1 or RQ. Okay, so that would be obviously what it is if we needed to list the side lengths in order from least to greatest. And now we need to do the same thing with the angles. So if I'm looking at the angles here, because that's what it's asking for, I see the smallest side is PR, which means the smallest angle is going to be the one that is opposite of that. So in this case, that would be angle Q. And we'll just name it by one letter just to keep it simple here so we're not getting confused on different lettering here. So angle Q is less than, try to make it distinct between the angle symbol and the less than symbol. Angle Q is less than, the next greatest side would be PQ, and the angle opposite of that would be R. So I'm going to say angle R here, which is less than the largest angle across from the largest side, which would be angle P. Okay, so this would be my final answer here. How do I list these in order from least to greatest? It would go Q, then R, and then P. And that's all I'm looking for, is which side lengths are biggest. That's going to correlate with the biggest angle. Okay, as long as I know how to find the opposite of it. Okay, so that's example 1 here. Example 2, we're going to have to do a little bit more. So I want you to take a sec. I want you to pause your video and sketch this triangle for me. Okay, so on this one here, we're given not necessarily the angle measures or the side lengths, but we're just given information about the angles. And using this, we want to list the side lengths and the angles in order from least to greatest again. Okay, so first thing I need to do here is I need to figure out what these angle measures actually are. So to do that, let's use what we've talked about before. We know all 3 of these angles in this triangle should add up to 180. So I'm going to take all these expressions and add them up to 180. So I'm going to say x minus 1 plus 2x plus 3 plus x plus 6 equals 180 here. All right? So we have this here. Now I want to use this to figure out what x is, so I can combine like terms since I have all x terms on the same side of the equation. X, 2x, and x are all going to combine to give me 4x. I can combine the numbers as well. -1, +3, and +6 are all going to combine to give me +8. Okay, so we have 4x plus 8 equals 180, and then we continue to solve. I can subtract 8 from both sides. These are going to cancel out, leave me with 4x. Now it equal 180 minus 8, which is 172. Okay, and then last step here is to divide by 4. Divide by 4 here. We get x equals, and if you like to, you can test your mental math and do this in your head, but otherwise you can just type this into a calculator, and that would end up giving you 43. Okay, so that helps us. We have x equals 43, but that doesn't necessarily tell us any information about them yet. So what we need to do is we need to use this and plug this back in to these angles here. Okay, so notice, let's start with angle P. Okay, we said that's x minus 1, so I'm just going to plug this back in here. So 43 minus 1. Okay, so angle P is just going to be 42 degrees. And I'm going to label that in my picture so I can visualize that and make sure I'm keeping track. Okay, next one here, let's go with angle M. I'll just go in order here. We know that's 2x plus 3, so let's plug that x back in. 2 times 43 minus 3. Or I'm sorry, plus 3, excuse me. Okay, and then I just need to simplify, so 2 times 43 is going to give me 86, and then 86 plus 3 should give me 89. So 89 degrees, I'll go ahead and label that as well. And then the last one, there is multiple ways we could figure it out. In this case, we'll just plug this back in here. Okay, angle Q here, it'd just be x plus 6, so just 43 plus 6. And that will equal 49 here, so 49 degrees. And if I really wanted to check my work and make sure I was doing this correctly, I could plug or add up all these numbers and make sure they add up to 180, which they will. All right, so we have all of our angle measures here, and now we want to do what the question was asking, which was we need to list these in order from least to greatest. So let's start with the angles on this one, since we're given information about them. Okay, well, we notice here angle P is the smallest angle, so we'll start with that. Angle P is less than, okay, I'll try to make that distinct, less than the next greatest angle. The next greatest angle would be 49, so that would be Q. So angle P is less than angle Q, which is less than angle M. Okay, you can use the less than signs if you'd like to. If it confuses you or makes the problem more difficult for you, you don't have to include the less than signs as long as you're ordering them from least to greatest. Okay, so we have the angle measures here, and we have ones are smallest and largest, and now that can help me understand what the side lengths are going to be in order from least to greatest. Again, not necessarily telling me what the actual side lengths are. Like, for instance, it doesn't mean that the side length across from P is going to be 42, inches or whatever the measurement would be. Okay, so side lengths here, we know angle P is the smallest angle, so the smallest side is going to be across from that, which in this case is going to be MQ. And I know this picture doesn't look like MQ would be the smallest one. I understand that. And I think it's kind of made to be that way because otherwise you could kind of just look at it and eyeball it and say, here's what I know about the side lengths. Okay, so MQ is going to be our smallest in this case, which is less than, if we look at our next greatest angle, that's Q. So the side length across from that would be PM. So I'll say is less than PM, which is less than our greatest side, which would be across from our greatest angle, which would be across from our greatest angle, which in this case would be side length PQ. And this would be my final answer for this one here. Okay, so making sure we're just using those ideas and being able to list in order from least to greatest. You'll have a good amount of problems that kind of practice that a little bit. All right, so that's one piece that we need to work on today. And then another piece here, another theorem that we're going to practice a little bit is what we call the triangle inequality theorem. Okay, triangle inequality theorem. So I'll have you guys write this down with me here. All right, triangle inequality theorem says this. It says in, let's see if I can write here, in a triangle, the two, or yeah, let's say it this way, the two smaller sides, let's say it this way, make it easier. We'll say in a triangle, the sum of two sides, okay, in a triangle, the sum of two sides will always be greater than the third side. Okay, in a triangle, the sum of two sides will always be greater than the third side. So I can choose any two sides that I'd like, doesn't matter which ones. I know that that sum or those added together is always going to be greater than the third. So for example here, let's have a triangle. Let's do a right triangle here. You guys can draw this a little bit bigger. I'm just cramped on space here. But let's say we make a triangle with side lengths 3, 4, and 5. 3, 4, and 5 here. Okay, what this is saying is if I pick any two and add them together, this should always be greater than the third. So for instance, if we just pick the first two, 3 and 4, 3 plus 4 is greater than 5, so yes, that checks out. Next one here, let's choose 4 and 5. That should be greater than 3, and that is indeed, so that should check out. And then last one here, the last set, 5 plus 3 should be greater than 4, which it is. Okay, so this should tell me if I can create side lengths with create a triangle with side lengths. If all three of these inequalities don't check out or they're not true, then that means I can't create a triangle with those. I can't have a triangle with those side lengths. Okay, so showing you how that looks in a problem here. Let's practice this a little bit. So example 3, I have 3 different side lengths. If you want to think of real life, you could think of maybe planks of wood being cut into these pieces. And the question is, can I create a triangle, or would I be able to create a triangle with these side lengths here? So I want you to write these down for me. Example 3. Let's say we have side lengths 4 feet, 14 feet, and then 7 feet. And the question is, can I create a side length? Or can I create a triangle? Excuse me. Okay, so the way I figured this out is I need to set up those 3 inequalities and make sure they all check out here. All right, so first one here, let's just choose the first 2 side lengths, 4 and 14. So I can say 4 plus 14 is greater than 7, and then you can just ask yourself, does that check out? Well, yeah, that's 18 is greater than 7, so that is true. Okay, so first inequality, done, we're good. And you do need to show this work if you have problems like this on your homework, okay? Next one here, 14 and 7, let's test those out. So let's say 14 plus 7, that should be greater than 4. Well, we know each of those is greater than 4 anyway, so if I add them together, that shouldn't change much, right? So 21 is greater than 4. That checks out as well. And then the last 2 that we haven't added together here, 7 and 4. So let's say 7 plus 4 is greater than 14. And we check, does that check out? Is 11 greater than 14? It is not. So since one of those inequalities fail, I can say, or I should say, that I cannot make a triangle from this from these lengths. So I'm going to write this out here, and I want you to write this with me here. No, a triangle can't be made. Okay, a triangle can't be made. And like I said, you guys could test this out in the real world, whether it be like big, planks of wood or something like that, 2x4s. You could test this out with pencils or anything, just little lengths. If you had 4 feet, 4 inches, whatever, you could not create a triangle with these, unfortunately. Okay, so that is some of the questions that we're going to see. And then there's one other type of question as well that deals with variables that we need to know how to do as well to close us out here. All right, so this will be our example 4. This will be our last one here. Same as always, I want you to pause your video and take a second, just sketch this diagram for me. Good news is that you don't have to label any points or anything like that. Just need to label these side lengths here. And we're saying on example 4, I'm given this triangle, and I want to determine the smallest length that x can be. So in other words, I'm going to set up my inequalities here, and then I'm going to figure out what's the smallest length, or what's the inequality to solve for x. Okay, so the way we do that is I'm going to look at this here, and I just need to pick 2 of the sides and set up my inequalities. So for instance, we have 3 feet and 7 feet. So we'll say 3 plus 7. If I choose 2 of the side lengths, that should be greater than the third. So 3 plus 7 should be greater than x. And then what I'm going to do is I'm going to solve this inequality, or in other words, get x by itself. Well, x is pretty much by itself. Now I just need to simplify. So 3 plus 10, or 3 plus 7, excuse me, we know is 10. So we have 10 is greater than x, or if I flip the whole thing around, instead of saying 10 is greater than x, I could say x is less than 10. So what I know from this is I know that x cannot be 10 and it cannot be anything greater than 10. It has to be less than 10. But this is just one inequality, right? Now I need to use this to figure out my other inequalities. So next one here, let's choose another two. Let's say we choose 7 and x. Okay, it doesn't matter what order we do them in. So if I add together 7 and x, two of the side lengths of the triangle, that should be greater than the third side, which in this case is 3. Okay? So I have this equality here, and if I wanted to solve it, I can't combine 7 and x, obviously. So what I want to do is I want to get x by itself. So in this case, I would subtract 7 from both sides. And here, we'll just write this below. Subtract 7 from both sides here. When I do it on the left, they would cancel out. So I'd just be left with x. Okay, don't need to worry about changing the sign. The sign just stays the same, facing the same direction. So we're going to say x is greater than 3 minus 7, which would just be negative 4. So we know x has to be greater than negative 4. Well, the problem here in this case is we already knew that because it's a length, and the length has to be positive. So that doesn't really help us out a ton, but we do need to check that inequality and make sure that it would check out. All right, and then last one here, we need to combine our last two sides that we haven't yet. So I'm going to say this last one here, we're going to say x plus 3 should be greater than the third side, which in this case would be 7. Okay, x plus 3 is greater than 7. And I do need to check this one as well and solve for x here. So to do that, I'm going to subtract 3 from both sides. When I do that on the left side, they cancel out. Don't need to worry about changing the sign. So x has to be greater than 7 minus 3, which is 4 here. Okay, so I have these two facts that I found by the end of this. I found that x has to be less than 10, but x does have to be greater than 4. Okay, so in other words, what is the smallest length that x can be? We could say, well, we know it has to be greater than 4. It can't be 4. So I could just circle this as my answer here. Or I could write it out, and we could say, let's scroll down here, and let's just say x, I want you to write this with me, x must be greater than 4. Okay, and the reason I'm focusing on that one is because I'm not worried about how big it can be. I know it has to be less than 10. I'm worried about what's the smallest length it could be. Well, I know at any length that's greater than 4. That would be my final answer there. Okay, so that is all the practice that we have with inequalities in triangles. I know I kind of moved through that, or kind of pushed through that pretty quickly. A lot of information. If you have any questions, as always, feel free to let me know in the Zoom call, but otherwise, rest of time today working on that 5.4 homework assignment. All right, thanks, guys.